Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. This is our last topic for PST 351, which are thermogravimetric analysis, also known as TGA. Okay, what is TGA? TGA measure the amount and rate of the change, which is the velocity in the mass of a sample as a function of temperature or time in a controlled atmosphere. So TGA is actually the instrument that is we use to measure the weight changes that occur in a sample with respect to the time. Either you heat it at isothermal mode or with respect to temperature. Okay, so the weight changes may be either positive or negative. It depends on the nature of the material that you want to study. And now we look at the notes. The TGA, we measure the changes in weight in relation to the change in temperature, and the measured weight loss curve will give the information on the changes in the sample composition or the thermal stability, the kinetic parameters for chemical reactions in the sample. So this technique can analyze the material that exhibit either the mass loss or the gain due to the decomposition, oxidation, or loss of the volatile matters such as moisture. If the material that you want to test will increase in weight after the end of the process or the end of the testing, it is normal because due to the initial oxidation of the material through the interaction with the oxygen from the atmosphere. So weight losses may result from the physical desorption of a gas or moisture to chemical decomposition of the material. And the nature of the degradation process is frequently affected by the atmosphere surrounding the sample, which in most instrumentation may be controlled through the use of appropriate inert or oxidative gas stream. So of course, when you use a TGA, it will need a gas flow. And now we look at the phenomena that causing mass changes. First, in terms of the physical phenomena, it involves gas adsorption, gas desorption, phase transition, either vaporization or sublimation. Gas adsorption is the addition of the atoms, ions, or the molecule from a gas, liquid, or dissolved solid to a surface. So it attached to the surface of the particle that you want to check. Okay, you want to test. So this process we create a film of the adsorbate on the surface of the adsorbent. And for desorption, it is a phenomenon whereby a substance is released from or through a surface. So the process is the opposite of adsorption. That is either adsorption or absorption. It is the process that occurs when a chemical or the element is converted from a liquid to a solid. And then, no, it is chemical element when it is the process whereby the liquid or solid will change to the gas form. So when a liquid is converted to a gas, the process is called as a evaporation or boiling. When a solid is converted to a gas, the process is called as a sublimation. Okay, for the chemical process, it involves decomposition, breakdown reaction, gas reaction, chemisorption, which is the adsorption by means of chemical instead of physical forces. Adsorption is actually the adsorption in which the adsorbed substance is held by the chemical bond. So means that the substance that is stick to the surface, it is actually held by a bonding, either covalent bonds, ionic bonds, or hydrogen bond. Now we proceed with TGA application. Characterization refers to the general process by which a material structure and properties are measured. So, therefore, for TGA, it can characterize three important things. First, the thermal stability. So, we can measure the thermal stability, which is the stability of the material to withstand the high temperature. And if it can withstand at high temperature, means it has more stable. So, it is quite difficult to decompose. Next, we want to measure the purity of the material, how much the percentage of the element presents at the end of the testing. So we can know the percentage of the purity by determining the um, what we call the percentage at the end of the reaction at certain temperature. And we also can determine the humidity. Okay, material purity is how much the percent is present at the end, while the humidity is percentage of the moisture content in that compound. TGA also can be used to examine the corrosion studies, which is oxidation or the reaction with reactive gases. We also can examine the gasification process, which is the process that convert the organic or the fossil fuel based on the carbonaceous material into the carbon monoxide, hydrogen, and carbon dioxide. So this is achieved by the reacting of the material at high temperature, especially more than 700 degrees C, without combustion, with a controlled amount of oxygen or steam. We also can measure the kinetic process of the material. Okay, so TGA application are widely important in food industry, petrochemical, pharmaceutical environment, and also in our industry, which is polymer. So TGA especially useful for the study of the polymeric material, including thermoplastic, thermoset, and so on. Because TGA, we can measure the weight changes in a material as a function of temperature or time under a controlled atmosphere. So its easy principle we use include measurement of material thermal stability, filler content in polymer, moisture and solvent content, and the percent composition of component in a compound. We also can check the amount of filler in the polymer resin. We can also check the carbon black content, the composition of temperature. Okay. You can also examine the moisture content of organic and inorganic material, the amount of plasticizer contents of the polymer, the oxidative stability of that polymer, the low molecular weight monomer in polymer. Because the TGA, if I can highlight here, it is performed by gradually raising the temperature of a sample by using a furnace. Okay, you need to weight the sample on an analytical balance that remains outside of the furnace. And then TGA will measure the mass loss if a thermal event involves loss of a volatile component. So the graph that you will get is sample is plotted against the temperature or time to illustrate the thermal transition in the material. So the y-axis is the mass and the x-axis is the temperature. The thermal stability of the material, it depends on type of the plastic and concentration of the additive. So it will affect both processing and the end use performance. So compositional analysis, thermal and oxidative stability will estimate lifetime prediction. First, in the processing, we want to ensure the incoming material are able to handle the temperature generated by processing equipment without thermal decomposition. And the second one, in terms of the end use properties, we can estimate the lifetime of the final product. Then you can estimate the lifetime of the material or your product and use end product by determining the decomposition rate of the material at certain temperature. Okay, TGA can reach a temperature above 700 degrees C. Okay, now we look at the TGA instrumentation. The instrument used in thermogravimetry, we call it as a thermobalance. So it consists of several basic components in order to provide the flexibility necessary for the production of useful analytical data in the form of TGA curve. Okay, now we look at the basic components of a typical thermobalance. We have the balance. The balance function to weigh the sample, and we have the furnace, which is the heating devices, unit for temperature measurement and control for as a programmer, and the recorder, which is the automatic recording unit for the mass and temperature changes. This one is the illustration of the TGA. Okay. Now we look at the most important part is the sample pan. Okay, it is left hanging here, and this one is a thermocouple, and you need to place the sample inside the sample pan and without the shaking properties. Okay, the sample pan cannot be shake because it will affect the measurement of the sample, the reading of the result. Okay. And we have the heater here, and we have the purge gas inlet together with the sample holder. So the sample must be placed inside the pan, and outside it has a furnace, and the purge gas is below the furnace. Okay, sample size is a few milligram up to 30 gram. Okay, freedom from vibration is essential due to high sensitivity of the balance, otherwise it will affect the result. A furnace temperature is measured by a thermocouple, and the heat from the furnace must not affect the balance mechanism. The signal from the thermocouple is transmitted to the programmer, and the temperature is compared with the required by the program set by the operator. Now we look at continue with the TGA instrumentation. Thermobalance will allow for monitoring sample weight as a function of the temperature. Okay, the y-axis is sample weight, so the x-axis is temperature. The sample will hang from the balance inside the furnace, and the balance is thermally isolated from the furnace. Depend on the temperature that you have set. Okay, if you set the temperature high temperature, so it will take a time to get the result. The sample is heated under nitrogen or the synthetic air with constant heat rate, while the difference of the mass during this process is measured. A mass loss indicates that a degradation of the measured substance will take place. So the reaction with oxygen from the synthetic air, for example, could lead to an increase of the mass. So for the gas system, we have argon and nitrogen. We want to prevent the unwanted oxidation. Also, we can use the oxygen and often switch during method program. Okay, this one is the example of the TGA curve. And we can see that the first sample is 2 milligram, and after the burning process, we can see that the temperature it start to degrade at 300 degrees C. Okay, you need to set the constant heating rate of the instrument, for example the initial temperature, the final temperature, and also the heating rate, for example 10 degree to 20 degrees C per minute. And the data is weight over time or weight over temperature. Okay, this curve is the data that show from 0 to 200 degrees C. It exhibit the loss of the water, and in the middle of 200 to 400 something, it is release of the carbon dioxide about 18%, and followed by the carbon dioxide. Okay, the remaining is about 38% of the material, or I don't know what is the sample here.